So hello friends, welcome again, and today we are going to solve a new question from our tree series, and this question title is symmetric trees. So in this question we have been given the root node of a binary tree, and what we need to do is that we need to find out that the given tree is symmetric tree or not. So this is the question, and in this example you can see that it has been given how we are going to judge a tree is symmetric or not. Now let's understand more clearly what is the meaning of symmetric in this case and how we are going to solve this question. So here I have taken the example one from the question, and this example you can see that there is an imaginary line between this, and if you consider this imaginary line as a mirror, so if you consider this imaginary line as a mirror, what is happening here is that there the left part of the given binary tree is creating a mirror image to the right part. That means the right part of the given binary tree is the image of left part, and the left part of the binary tree is the image of the right part. So this should be mirror image of each other. So if this is that, that means the if you create a imaginary line between the given binary tree, then you should be getting the mirror image in the left and right part. So if this is the case, then what we can say that this tree is a symmetric tree. Now, how you can say that a tree is a symmetric tree? So what we need to check is that the values at a certain distance or fixed distance to the left and the right should be equal. From the certain distance, here 4 and 4 should be equal, and here 3 and 3 should be equal. So the equal distance nodes from this line should be equal, or their values should be equal. So how we are going to check? Let's see. So let's first check for the root node. So the root node is lying on the mirror. So if any object is lying on a mirror, so there is no creation of the image. So we do not need to check for it because it's already satisfy the condition of symmetry. Now what we have to do actually is that we have to make sure that this left part and this right part are the mirror image of each other. So if you see that these two are at the same distance, so that means we have to compare this. That means these two nodes should have same values. This is the important criteria. So what we are going to do is that we are going to check that these two values are same or not. So you can see that these are same. Now after this, what we have to do is very important, that there are two paths in which we can move. First is left and second is right. So if we are moving to the left from this node, and then where you have to move in the second node, which is this, you have to move to this side. So here you can see that if you are moving to the left side, here you have to move to the right side in order to get the position of the node which is equidistant from the mirror. So if you need to find the nodes which are equidistant from the mirror, we have to move in the opposite direction in the both nodes. So here you can see that what we are going to do is that we are going to run a recursive function, and using that recursive function we are going to go through the complete nodes, and we are going to compare the values at equidistance from this center. Now the functions, what you can say that the recursive function should contain two nodes. First you can say left node, second will be our right node, and these are the two only we needed. So what we have in our hand is that we have one this node which is 2 and this is 2. So this is the first recursive function which we are going to call. So after this recursive call, what we are going to do is that first we need to make sure that these two should not be null, or anyone should not be null. It should be also following the structure. That means it doesn't be any case that here 2 exists and here 2 is null. That means it has only left part. So in this case also it is not a symmetry. So we have to make sure that that case also not arises. So we are going to check for the stopping condition for recursion. So what are the stopping condition is going to in this case? So the first stopping condition should be if the both the nodes, that means left and right, are null, that means it is the leaf node. So if we are arriving at a leaf node, then what we are going to get is that its left part and its right part are going to be null. So that means it is a leaf node. So we it is true. That means we have satisfied till now. That means until our recursion we are getting all the values same. So what we can simply do, that if we are getting that our left is null, that means if we are getting our left and our right is null, so what we have to do, we have to return what we can return, we can return true, because all is fine. Now another case is important, that what happens if any one is null and second is not null. So in this that case, let's assume that if we are getting one null, or yeah, we can use or condition, that means any one is null and any one is not null. So if this condition arises, so what we can do, we can return false. So these are the two conditions, or you can say stopping condition for our recursion. We need to check in order to go through this recursion. So if you check these two condition, now next important condition which you have to check, that if the values are same or not. So a stopping condition is clear. That means the nodes are valid nodes. There is no null node. Now simply what you will check if the left value left value is equals to right value. So if the values are equal, so what we can do, we can simply return true. So for this case, we are going to check if it is not equal. So if the values are not equal, you can simply return false. So I assume you have understood three conditions, which is important and which is going to come in our code, and which is also important for recursion. So these three conditions we have checked. First, we have checked that if both the nodes are null, we return true. If any one node is null and one is not null, we return false because it doesn't follow the structure. And if the values are not equal also, then we return false. Now only one condition is left. Let's take care of that condition. So the one condition which is left is that what if our values are equal? So here is the condition where our values are equal. So in else part, what we are going to do, so in else part what we are going to do is that we are going to call for the recursions. Now it is important, let's concentrate. So what we have is that we have seen that in order to find the node equidistance from the center, we have to move in opposite direction. So if you want to move in opposite direction, that means we have to call a function, and at we already have, you can see the first recursion call is our left and right, so this is already called. Now inside this function we are calling this. Now what will happen, we will call another function which is left 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 left, and our right right. So this function we are going to call, and this is going to check for this 3 and this 3. Now the next which we are going to call is function which is left right and right left. So this is going to check for this 4. Okay, so these are the two functions which is going to call recursively every time for each and every node. And using this node we are going to check for another or upcoming nodes if we have here another nodes here linked. So it is also going to call for this also in the upcoming recursion calls. Now what we need to have to do is that we have to use AND operator. So if both the function calls returns true, then we return true, and if any one returns false, then we return false. Now let's understand it by coding part, that how it is going to be work. So let's start by, here you can first check the constant. So here you can see that the number of nodes in the tree are ranging from 1 to 1000. So it is sure that the first root is not going to be null. So we do not need to take care or think about that. So what we are going to do, we are going to create another function bool check, and here what we have two tree nodes. First is going to be our left and second is going to be our right. Okay, now let's call this check, and what we are going to provide this check, we are going to provide left and right part, root left comma root right. Okay, so we can simply return it. Okay, now let's concentrate on this function. So in this function we have firstly checked the three conditions, which is a stopping condition, two stopping conditions, and one is the condition required to check the values in the nodes. So the first condition which we need to check is that if our left is not null and our right is not null. So if this is the case that those two values are not null, so those two values are null, so what we have to do, we have to simply return If those two values are null, that we can simply return true. That means we have do not need to check for the symmetry, because we have already checked the symmetry till now, so we can simply return true. Now another condition which arises, and this is going to cause a issue of a structural inequality. That means if any one left or right is null and another is not, then we have to return false. Now next condition which we have to check is for the value. First we have checked stopping condition, second is checking the structure, and third is going to check the value. So in this we are going to check if our L is not equals to our right value. So if this is the case, then we have to return false. Okay, now in else part which we are discussing. So in else part we are going to call a recursive function, and let's simply write it here. So we are going to call check, and the first call is going to be left, left, and we have understood that in order to get the node equidistance from the symmetry line, we have to call right, right. Okay, and condition, and again another function check our left. Now we have called for the left, now call for the right, and similarly for the right we have to call for left. Okay, now let's return this also. So we have to simply return this. Now let's run this code. So this is accepted. Now let's submit this. So this is accepted successfully. So this is the question for today, and from this question I am sure that you have understood the questions related to symmetry. What we are doing in three steps. First, recursive function, then stopping condition, then structural equality, we are checking that the structure are same or not. Third, we are checking the values, and fourth, we are calling the recursive functions for opposite directions. That means left, right. So right, left. Okay, so this is the complete solution for this question. Now we are going to see the solution for both Java and Python. So stay tuned, and let's meet in the next video where we are going to solve a more interesting question from the tree. Now let's keep exploring and keep tuned to our YouTube channel. Thank you all.